right. So as I mentioned, it's great to have Shelby Marshall here with us throughout the conference, playing so many roles, and glad to have your talk, and glad that I get to see it actually as it's turned out. So I've been looking forward to this. It's using online simulations to explore complex topics and apply systems thinking. And Shelby comes to us from Fable Vision in Boston area, and it's a pleasure to have you here. So I can turn it over to you and let you take it away.
Well, thank you so much. And I guess I really appreciate the organizer, David, and the rest of the organizers for finding a new slot for me. I was all set to get started yesterday, and really 5 minutes before I was supposed to get started, the internet went out, and I ended up calling Spectrum, love Spectrum, and the whole area was out for hours. So it was lovely. But here I am, and I really appreciate it.
I'm glad it worked out. And I know you were online, the entire day, all the time. You were chairing sessions, and then of course comes to your own presentation and the outage. So I'm glad they got it fixed. Yeah, I'll let you take it away. It's great to have you here.
Thank you. So a little bit about me. I'm the Vice President of Strategic Partnerships and Product Solutions at Fable Vision Studios. As David said, we're in Boston. We're educational media developers, and I'll give you a little bit more about Fable Vision in a moment. But first, I want to say that, and actually, I should share my screen. So let me do that. Here we are. Okay. So I work with our clients and partners to explore potential partnerships and to develop the initial analysis of their needs and goals, translate those into a project plan. I have a bachelor's degree in science in biology from Cornell, and a master's in museum education from George Washington University. So I've actually been in education for over 40 years as a museum educator. And then I joined Houghton Mifflin, and I was a science textbook editor. And then when instructional technology happened, I joined that group, and I was a project manager. I've been at Fable Vision since 2005. And so I map out strategy and conceptualization of the ecosystem for complex projects. And I've worked on a lot of software products, websites, games, books, animated films, presented at various workshops for museums and for education publishing in particular, serious games, animated videos, and whatnot. So that's me. Let me say that actually, let me just give you a preview of what we're going to do in this next half hour. So first, I'll tell you a little bit about Fable Vision Studios. We developed the simulations I'm going to show you, and then I'll give a brief overview of digital simulations, highlighting their purpose and value. I'm going to show you 3 examples of different levels of complexity and covering different subject areas, and then we'll review and answer questions. So Fable Vision Studios, as I said, Boston-based. We were founded in 1996 with a mission to use positive media, storytelling, and technology to move the world to a better place. And we really honestly live that mission. We're not just knock stuff out. We've turned down jobs that were not compatible. So we create games, simulations, and other digital activities, animated and live action films, online curricula, websites, mobile apps, interactive museum kiosks, and books. And our clients and our partners include a broad range: publishers, corporations, educational and nonprofit organizations, broadcasters, museums, healthcare organizations. Essentially, we believe that thoughtfully designed multimedia technologies can open doors to new ways of learning, communicating, and interacting. So what are we going to talk about today? I'll give you a brief overview, like I said, show you 3 examples that are different levels and topics. Fabulation is a bridge between research and practice. And it's interesting following the presentation that we just had, because we do go to, we deal with both academic and pre-K through college and adult learners. And so the simulations I'm going to show you, they draw upon research, but I'm not going to talk about research. My focus today is practical. It's really how do we apply what we know about learning design and to this form of media. So I want to give you concrete ideas that can inform your plans. So if you think about, I'd like to use simulations, I'm really sure, how to go about that to make it most effective. So post questions in the Q&A. At the end, I'm going to give you a link to an online project gallery that has these examples in it, and also several other examples. And we only have a short time, so really feel free to contact me after the session. I love talking about this stuff and exploring it with folks. So, overview of simulations. It's really simple. A simulation is a technology-based program that contains a model of a system or a process. If it doesn't simulate a system or a process, it's not a simulation. It's pretty straightforward. There is an overlap between simulations and games, and the differences are not always clear. And sometimes a thing can be both a simulation and a game. Games are purposeful, goal-oriented, and rule-based, and games usually put the player in a struggle against some kind of opposition. And of course, some games model a system or process, but many of them don't. One essential aspect that separates some digital games from simulations is that simulations typically don't include game dynamics or have the win state that you typically have in a digital game. But it is not cut and dry. Sometimes a game's a simulation includes game mechanics. The definitions are only useful up to a point. And I've included a few examples of games that are simulations in that project gallery I mentioned. But in any case, regardless of the differences, and the fact that they, either one can have collaboration or competition built in, simulations and games give learners the freedom to fail and try again, learning from their mistakes until they find a better way. And that is critical. Simulations can be used, I need to put the little window of pictures of people that's in my way. Simulations can be used to improve players' knowledge and skills, including technical and functional expertise, analyze complex systems, enhance teamwork, problem-solving, decision-making, and critical thinking. So in all of this, keep in mind that a simulation as a learning tool is more than just a model. To accomplish these things that simulations can be used to do, the student has to be able to keep trying something, fail without judgment, reflect on what went wrong, try again, and keep trying until they get it right. And presumably, hopefully, they understand why it worked when it did. And of course, some of these things can be provided by a teacher or by the context in which a simulation is delivered. But by the time a learner is done working their way through a simulation, they should have had these experiences. Trying, failing, try again, get somewhere, and know why their successful choice actually was successful. And it's interesting as I think David discussed in his introduction on Monday, certain themes about learning. And I think simulations and games particularly fit those themes about engaging the learner, providing an individualized experience with freedom to fail, preparing the learner to function in the world. Which I think is just tremendously valuable. And at Fable Vision, frankly, we are asked to develop simulations and games for K through 12 far more than for higher education and corporate training. And I think that's a missed opportunity. I would love to see simulations integrated into college and adult courseware more frequently. And one reason, thinking about sessions I've attended today, this week, it's unfortunate that at college level, this is just an aside, individual instructors, professors, are responsible for developing their own online courses by and large. It's growing, but unusual still for a college or university to have a department with its own instructional designers to help produce courseware. And you just can't ask a professor to create an online course that is engaging and uses multimedia and things like simulations. It's unrealistic. But that's aside. So now I will show you some simulations. The first example is Weather Lab, which we created for the Smithsonian Science Education Center. And the audience here is middle school, but the instructional design and the interactive design that we used are applicable really to all levels. It explores weather, which is a complex real world process. And it does so by looking at the interaction of just 3 variables. The model shows how the variables interact. And one thing that's really important is that students have to make a prediction, and the program responds to the prediction. So it won't run. You won't actually see the simulation run unless you get a correct prediction. So let me now, I have to do a little bit of switcheroo here. This is the website where it lives. I'm going to launch it. And now I have to switch my sharing. There we go. Okay. So Weather Lab. It's, as I said, it's pretty simple because we want to make sure that students can dive right into the data. So you see the green box on the left, ocean current. You pick an ocean current. And then you go look to the box, the orange boxes on the right, and you got air mass 1 and air mass 2. So pick one of each. I'm just going to go for that one and for that one. And you see that each one comes with a little bit of information about what it is and and how it affects things. Now we go down to the bottom. Think about how these air masses and ocean currents will interact, and then click next to make a prediction. Okay, so we're thinking. I hope you're all thinking. I hope you are ready to make a prediction. If we were doing this live, I'd ask you to come up with something, but unfortunately, I have to do this myself. So if I live in the Southwest, I should put on rubber boots. There's going to be heavy rain and flooding. Put on a winter sweater. It's going to be cold. Or wear normal school clothes, but put an umbrella, pack an umbrella just in case it might rain. So I'm going to give you a moment to think about that, and then I'll make a choice. Okay, so I picked the third one, and there it is. I see the model running, and I get an explanation for why that was correct. Warm tropical air of the maritime tropical air mass is carried by Pacific Ocean and meets the warm, dry continental tropical mass coming from the desert Southwest, etc. So it gives you all that. And now I can reset it and try a different combination. So, this is a very simple model, a very simple simulation that pulls out, it gets at just one small aspect of a very complex situation. But it teaches a couple things, because one of the goals here was making predictions, and another goal is thinking critically. So even though it's really a kind of simple model, it engages students in higher order thinking pretty effectively, and it gives them a chance to just keep messing around, trying things, and see, oh, that didn't work, or I thought it would be this way, but now I learn why. And I'm going to tell you with all these three examples what the rough approximate cost to develop them was, because I want you to understand for your own practice, what would you have to get into to build something like this. So it costs about $45,000 to make this. Now I need to stop the screen share and go back. All right. Next example, my Econ Lab. So this is a simulation of a totally different order, because this was developed for Pearson for undergraduate students. So this is a complex system, and it's a complex simulation. My Econ Lab is part of Pearson's My Lab and Mastering. It's a collection of online homework, tutorial, assessment products for higher education. And it teaches basic economics through five interactive experiments. Each one covers a different concept in the economics curriculum. And the purpose is to model real-world economic activities and outcomes. So the experiments are multi-user and multiplayer. Students can play inside and outside the classroom. And they can play both synchronous and asynchronous play. And if they're doing it in the classroom, there's tons of controls for the professor. So the professor can set up the parameters for a particular experiment and can set it up to be synchronous and have students in the class start at the same time and end at the same time, either playing collaboratively or competitively. You can also play against the computer. And there's just a lot of control given to the professor to make sure that whatever they're working on is going to be reflected in the simulation. So before I really get into this, well, I can say we developed this several years ago. I can't log in, so I'm showing you several screenshots. So here is one screenshot that has this is, I believe, a synchronous activity, and you can see that the students are divided into a group of sellers and a group of buyers, and in this case, you're a seller, and the students can adjust the prices of the product to learn about supply and demand, price equilibrium. They basically they bid, you set a price, an asking price. The other group sets a bid, sees if can you get the price you wanted. And as you move through it, the experience, there's a lot of different screens that give you data and ask you questions to think about the data. We built in a chat tool so that students can talk to each other. With their, especially to support collaboration and learning from peers. And here's just one example of data table that's available for the professor. So again, more different displays of data, lots of different ways to present data to the students so that they can analyze the data, make decisions, try things out, and at the end, export their results. So I think you can probably see, even just from this brief little view of this, that students are going to learn about how markets actually work far better from a simulation like this than from book learning and from passive learning, from a professor talking to them, from PowerPoint presentation or whatever. And in contrast to the other simulation I showed, the Weather Lab, This cost about $500,000 to develop. Now for a very different thing. Noodle Partners found that college courses, they develop courses with colleges. And college courses in areas such as education administration seldom give students opportunities to apply soft skills such as empathy, judgment, or ethical practices. So this simulation is here to fill that gap. The player tries different approaches with, in a real world interaction, sees what happens, tries again. And it's a series of decisions. So you face these decisions, how to deal with this other person. You see the reactions and you adjust your approach. And the player can do well or poorly. And there's a lot of branching, which you'll see in a minute. So when you get done, you can have done well, you can have done very poorly, or somewhere in between. And if you didn't do well, you go back and play it again and make different decisions. So, it's there. We designed this and wrote the script so that students are applying decision-making skills relating to stakeholder relationships, different components of stakeholder perspectives, understanding multiple points of view, analyzing, evaluating stakeholder input, and taking their problem-solving strategies and applying them to a novel context. Also, I think what might be interesting is that we built it as a reusable template, so it can be reused with new content, with more or fewer decisions in different content areas. So now I'm going to share it, and I need to actually switch over to this screen as well. Okay, we're back. So I'm going to just kind of walk you through the intro. It's a pretty intensive introduction because you really need to know what you're getting into. So you're the principal at this high school, and you advise and support new senior administrators. And now we have a new principal at the middle school, Sharon Lopez. So we get a little bit about Sharon and Sharon's history, but where she comes from, what her attitudes and values are. And a little bit about the school. This school has had 4 principals over the past 5 years, and there's a lot of animosity between the administrators and parents. So there's an adversarial relationship between the administration and the English Learners Advisory Committee, which is a group made of various stakeholders. And Sharon, the principal, needs to establish a strong relationship with this committee, and especially with its chairperson, Irma. So we learned a little bit about Irma. There's Irma. And Sharon has reached out to Irma to set up a meeting. So now Sharon's looking for your expertise and help to navigate her first meeting with Irma. Now you're not on your own. You have 2 team members from the middle school to help guide you. And you're going to hear from them over and over again. So Irma suggests meeting at a bar. Now you can replay these bits of advice, but now it's up to you to make a decision. What should Sharon do? Agree to meet at the bar, suggest a new restaurant nearby, or recommend meeting at the school instead? So I don't have a whole lot of time left in this session, so I'm going to just make a choice here. But each of these choices would actually lead to a different reaction on Irma's part. So I'm saying agree to meet at the bar. And Irma responds, this is obviously text messages, looking forward to meeting you there. So now they're seated at the bar and we begin a whole new decision. So I really don't want to run out of time, so I'm switching back to the Zoom, which I hate to do because this stuff is so much fun. But it's interesting that each decision has immediate ramifications because Irma's reaction is going to be different, and then if Irma has a bad reaction, then basically Sharon's in defense mode. She's got to do damage control, and so the next decision that she's faced is very different because Irma's got something different to do. This is, I thought you might enjoy seeing this. This is the branching map for this, for the program, for the software that we use. This is the software we use to make the decisions and their outcomes. So there's tons and tons of branches, but we designed it so that it would kind of resolve down to just a few possible outcomes by the time you're done with all 8 decisions. And it might surprise you that it cost only $70,000 to build this thing. Each reskin would be maybe $10,000. So let's quickly review. Digital simulations let players alter and adjust aspects of a virtual object, device, or person in a way that facilitates learning and practice. That's the point. They can be used to do a variety of different kinds of things. They can be constructed as games, and they can go from small, focused on only a narrow set of topics to large, covering a broad set of concepts and skills. No matter what, they need to give players opportunities to learn and to apply what they know. And there are lots of other kinds of simulations, and I focused only on a few that I think are roughly affordable. And I think honestly, it's really of value to insert small focus simulations in the curriculum. And when you think about them, designing a simulation or game, it's like planning any other kind of instructional event, experience. Start with the learning objectives, consider the learner and the context, and then go from there. So please feel free to contact me afterwards. I know we have time, hopefully, for a few questions, and you can see the project gallery there and my contact info.
All right, no, fantastic. Thanks so much. No, we wish we had more time to see more demos, but this is great. So two quick questions. One is from Annalisa. Can you tell us what the name of the software is that created the map of the dialogues that you the branching map?
Yeah, we used Twine, something called Twine, and it's really great. It's got some limitations. It was kind of a pain to use in some ways, and so we're actually looking, if we do a new one, we're going to probably use something different.
Okay. So
I'm happy to talk. Reach out to me, and I'll let you know what we're looking at now.
Okay, fantastic. And then the second question is, well, first starts with a comment. Great presentation, great technology. Do you assess the efficacy of the simulations in student learning? Are you able to do that? Because we're basically a work for hire shop. We can only do assessment if that's part of the project. Our clients have, some of them do and some of them don't. Some of the things we build are part of research projects, and so
we get a lot more assessment of effectiveness in those situations. It's a mixed bag.
Yeah, no, that question did not come from me, but I certainly understand that, and it's a challenge to get clients to really take the time to evaluate things, and I definitely understand that. Are there is there anything you can speak to about how the assessments are done when they are done? You know, how those work.
In some cases, you know, it's a really full-blown research project with questionnaires, observations, a control group that's learning through a different, you know, a different medium, you know, designed by a proper evaluation firm like EDC or Knology. Sometimes it's just the kind of evaluation that a publisher would get from you know, or teachers would get from any form of instructional media, you know, to see you know, how well does it do at preparing students for a test.
Great. All right, well, thanks so much. I feel like we could talk forever. I wish we had more time. I know you're around the rest of the conference. You've been around so much, helping chairing and everything else. So we can continue discussions through the chat and through you know, Huva and through other, you know, other methods now and in the future. It's great having you here. We're going to wrap up the session, take a lunch break back at 1:30 with more parallel sessions. So thanks again to everyone for all the great questions, and Shelby for the wonderful presentation, and all the others in the session. So thanks everyone, and we'll see you back here at 1:30.
Thank you so much.
Thanks again. Take care.